Okay, Dr. Cook here. In our last video, we introduced some forces from drag as we go through a fluid. But I want to talk a little bit about Magnus and spin damping and some of the other things that are happening to our bodies as we move through, or rigid bodies as they move through a fluid. The first one is this Magnus force. Okay, now this is caused by flow over a spinning body, right? As something is spinning. Now this force acts perpendicular to the spin axis. All right, so we got to know what our axis is spinning, and this will kick us off to the side. So what's going on here? If we start with a spinning cylinder, let's say, right? We're looking at it from an end view, all right? And we spin this thing with some rotational velocity, all right? And then we put it into a fluid flow moving at some velocity v, okay? Now, what's going to happen here is on the top and bottom of the cylinder, then the relative velocity of the fluid is going to be different. All right. So in this diagram, the way it's spinning on the top there, it's going to be that rotational speed minus the fluid velocity, and on the bottom, it's going to have a relative velocity of that rotational speed times the radius plus that velocity. Now, what does this do? This causes the pressure on top to go up and the pressure on the bottom to go down, all right? And because we've got a pressure differential, we're going to get a force pulling us in that direction, okay? So this is what causes our force off to the side. It's perpendicular to our spin axis that we're spinning around. Now, how do we calculate how much force we have? Well, we've got an equation for that, all right, right out of the book. This is 712, okay? Looks a lot similar to some of the other forces we've seen, but now we're bringing in this rotational velocity and our length term there. In this case, we're using diameter, and our velocities all around it. Okay, and we've got a different coefficient here. C sub n is the one here that we're using with this Magnus force. Now, this force is typically small and negligible for what it'll do compared to a lot of the other things we're dealing with. Okay, so I want to do a little bit of a demo here about Magnus to help you understand this. Okay, so what I've got here is just two lightweight plastic cups taped together, right, to create a rigid body that we can spin. Okay, and I'm going to take this little piece of string that I've got here, right, and we just wrap it around it. Now this is to impart some rotation into this as it falls down, okay? We're not really trying to get a sideways force acting on this. We're just trying to spin it up as this thing drops. Okay, the next one we're going to talk about is the Magnus moment. All right, now this is a moment about the axis that is perpendicular to the spin and that Magnus force, okay? So perpendicular to the spin and the Magnus force. Here's our other axis. This is a moment that's going to rotate our body. All right, we have an equation for that, and for the Magnus moment, we've got subscripts of m here on our coefficient and our moment term. All right, and again, we're bringing in a lot of the same kind of variables. Now, the Magnus moment is relatively large, okay, and it's going to have a big effect on our pitch and our stability as our projectiles are moving. Okay, the third one is the spin damping moment. Okay, this is another moment here. This has to do with the viscosity at the surface and how it slows our spinning. Okay, we're damping down our spinning, slowing it down. This is a moment about the spin axis. That's how it counters the spin. Okay, and we have an equation for that. Again, bringing in some of the same terms here. This is equation 7.5 in the text. All right. Now to go over what some of these things are, we've got this P term in here. All right, that is the axial spin in radians per second. So how fast are we spinning is one of the factors here that affects this, along with our viscosity and velocity and presented area and all that other stuff that we've been dealing with before. Okay, so that's the end of the video, and this just gives you some of those other forces and moments acting on our projectiles that we can calculate. See you in class.